I welcome you all for this wonderful video lecture series on operating systems. Today topic is fragmentation. Before that, I introduce myself. I'm Shankar. I'm working as assistant professor in the Department of Computer Science and Engineering, RMD Engineering College, Chennai. Let's start the lecture. With both, previously we had discussed the allocation method, first bit, best fit, worst fit, and so on. In this, the first fit and best fit strategies or memory allocation, it suffers from the external fragmentation. These are all actually we have discussed. Let's just go through it. In the last video lecture series, actually, we have discussed this. As per the processes are loaded and removed from the memory, the free memory space is broken into little pieces. External fragmentation exists when there is enough total memory space to satisfy a request, but the available spaces are not contiguous. Storage is fragmented into large number of small holes. It means that we have enough memory space. For example, if you have free space look like this. Sorry for this diagram. Okay. Yes, if we the memories look like fragmented, look like this, right? Maybe this portion is allocated, right? And this portion is allocated, right? This may be free space with 1 KB, and this may be with 2 KB. For assumption, I'm telling, right? 2 KB, and this again you may have this is maybe allocated. You just think, imagine this is all allocated, and this may be 3 KB free space. So totally how many free spaces are there? 6 KB free spaces as per this memory allocations are available, because here 1 KB is free, here 2 KB is free, here 3 KB is free. Totally 6 KB we have free space in this memory. I want to allocate 5 KB process in this memory space, right, in this memory space, but it is not possible because that 5 KB I need continuously I need. It's not like here 1 KB, here 2 KB, 3 KB. I cannot able to allocate like 3 KB here, 2 KB here for this process. I need only 5 KB spaces continuously. So in this case, even though if there's free spaces available here, I'm unable to allocate the file or process here. That's the problem, right? That's actually discussed here. External fragmentation exists when there is enough total memory space to satisfy the request, but the available spaces are not contiguous. See, here I need only 5. It's available really, but I'm unable to allocate because it's not contiguous. So the storage is fragmented into large numbers of small holes. This fragmentation problem can be severe because we had a space, but we are unable to allocate the files. So in the worst case, we could have a block of free, that is space free memories between two processes. If all these small pieces of memory, there is one big free block instead, we might be able to run several more processes. This property is known as 50% rule. Memory fragmentation can be internal as well as external. If you consider the multiple partition allocation scheme with the whole of this many bytes, 18,464 bytes. Suppose that the next process requests 18,462 bytes. If we allocate exactly the requested block, we are the left with the whole 2 bytes, because the whole with the memory whole allocation byte is 18,464. The request is only 18,462 bytes. So we have 2 bytes free. So the overhead to keep track of this whole will be substantially larger than the whole itself. The general approach to avoid this problem is to break the physical memory into fixed size blocks and allocate the memory in units based on the block size. With this approach, the memory allocated to a process may be slightly larger than the requested memory. The difference between these two numbers is internal fragmentation, means unused memory that is internal to a partition. One solution to the problem of external fragmentation is compaction, right? Once again, you should remember a solution to the problem of external fragmentation is compaction. Then what is compaction? We have to arrange all it into sequence of free space, right? The goal is to shuffle the memory content so as to place all free memory together in one large block. Whatever we have explained here, if we keep all together as single block, all six, then it is possible, right? Yes, that is the compaction. Another possible solution to the external fragmentation problem is to permit the logical address space of the processes to be non-contiguous. So why we have faced problem here is because of contiguous block allocation, right? Because of contiguous block allocation only, we are unable to allocate a file with the 5 KB in this example. Suppose if we changed with contiguous to non-contiguous, it is not problem, right? We can allocate 2 bytes for somewhere and 3 bytes somewhere. So totally 5 blocks we can able to assign. So the another solution is we should permit the logical address space of the process to be non-contiguous, right? This is another solution. Uh, I thank you all for watching this wonderful lectures regards fragmentation. It's just intro only. We have not discussed in detail, right? Yeah, I thank you all. Thank you.